I hope you're all doing well. On today's AI Inquirer, we're going to challenge AI to see if it can figure out how to stack some blocks. It's a simple problem, not a very practical one. Probably no one will run into this unless you happen to be a toddler. But I have 4 blocks right here, and the question's going to be how many different ways are there to stack those blocks so that they won't fall over? And I'll kind of demonstrate that in a second. But to solve this problem, AI is going to have to retrieve information that it already knows and combine that information in a rather original way to come up with a solution. So let's see what happens. So here's 6 ways that you can stack those blocks. The first way is you can have one layer of 4 blocks on the bottom. The next way is you can have a layer of 3 blocks on the bottom with 1 block on top of that layer. Another version is you can have 2 blocks on the bottom and then another layer with 2 blocks on top of those. A fourth way has 3 layers, 2 on the bottom, 1 in the middle, and 1 on top. A fifth way is to stack all 4 blocks one on top of the other so you have a straight 4-block tower. Now the last one is the tricky one. You can have 1 block on the bottom. On the next layer you can have 2 blocks, but you can only put those 2 blocks there if you put the last block on top of them. The last block is able to pin those 2 blocks so that they don't fall over. So here's our problem statement. I have 4 identical blocks, each one in the shape of a cube, about 1 inch on a side. Describe how many unique ways all 4 blocks can be stacked on a flat table so they are self-supporting without adhesive. The array of blocks can be up to 4 wide or 4 high, but only 1 deep. Rotation of the blocks does not count as a unique configuration. Configurations with the same number of blocks on a given level are not to be considered unique. So I gave this query to Gemini 3.6 Flash, and let's see what it came up with. We can see that it identified 5 of the unique configurations for stacking the blocks without them falling over. But guess what? It didn't catch the one configuration that allowed 2 blocks to be placed in the second level with the last block on top to pin them in place. So this was a little bit surprising, but maybe not unexpected. So let's see what happens when we query Gemini and say, hey, what about this configuration? Here Gemini just becomes downright stubborn, and it insists that that configuration is physically impossible. It comes up with a rule that says for any block level L, the number of blocks cannot exceed the number of supporting blocks on the level below it unless the center of mass of all upper blocks remains strictly over the base block below. So then we went ahead and submitted a picture of the configuration and said, hey Gemini, look at this. Now what do you think? Well, apparently in light of photographic evidence, Gemini admitted that yes, that does seem to be a physically possible configuration. And then it went on to explain, well, yes, I guess the block on top on the third level is able to pin the 2 blocks below it and keep them from falling over. So then we went ahead and asked Gemini, well, how do you know that that photo is an AI generated or the blocks were glued together? AI went on to explain that, well, I don't see any reliable signals that were detected in the image indicating how the content was created or whether it was AI generated. So it accepted the picture as being valid and agreed that that's a physically possible configuration. And then it went on to say, well, is it practical? Well, maybe not. It sounds kind of tricky to get the 2 blocks with the 1 on top. And if you notice, yeah, I had to kind of hold on to those 2 layers at the same time, 2 levels together at the same time to get them on the bottom block, but it did work. We then went ahead and asked ChatGPT the same exact question. And the version of ChatGPT that we asked was version 5.6-Luna. ChatGPT came up with the same exact answer, or the original answer that Gemini did, that there are 5 unique configurations for stacking the blocks, and ChatGPT also missed the fact that you can have an arrangement with 1 block on the bottom, 2 in the middle, and a third one on top that pins the 2 in the middle and keeps them from falling over. I submitted the same photo to ChatGPT, challenging its assertion that the 1-2-1 configuration won't fall over. ChatGPT accepted that the photo proved the fact that that was a stable configuration, and so it decided to revise its answer based on that photograph and said, well, okay, it looks like there are 6 legitimate configurations for stacking the blocks without them falling over. So what can we take away from this exercise? It looks like ChatGPT and Gemini were ultimately able to accept the correct number of ways that you could stack those blocks, including the one that I suppose could be considered kind of tricky, where the 2 blocks in the middle are pinned by a block on top to keep them from falling over. And when both of those AI models were challenged, they both understood the physics of what was going on and accepted that configuration. But I think what's interesting, though, is when they both AI models were given the problem to consider, even though those models have enough information to understand that the configuration they missed would work when challenged, they aren't creative enough to kind of figure out all the different ways that it could possibly work. In other words, there's kind of a lack of creativity involved, and instead, both the models, since they are large language model based, they tend to look for words that connect to what you're asking. So when you ask those models, how can I configure these blocks? It first kind of comes up with all the possible permutations. And then when it understands that, oh, they can't fall over, then it assumes that you have to have 1 block underneath each block on the layer above it. It does understand when challenged that you can come up with an alternate way of making the configuration stable, but it's not a recursive type of model that's able to challenge its own answer and then think of another way, even in the realm of the knowledge that it possesses, that there's another way to stack those blocks. So altogether, while it's not necessarily a very useful problem, it represents the fact that maybe for a more practical or useful problem, when you blindly give it to an AI model, it lacks the creativity and perhaps the thinking ability to consider the possible solutions to the problem. And it's only going to give you a solution that I'll say is most closely connected to the repertoire of knowledge that it has already. So I hope you enjoyed the video, and I hope you subscribe to the AI Inquirer channel. Thanks. Bye.